Okay, in this video we're going to be looking at some more proofs involving parallel lines. And just like the proofs involving parallel lines that we looked at earlier, we're going to be making use of some postulates. And if you recall, in the previous video we looked at some proofs in which we used the corresponding angles postulate as one of our reasons in the proof. The corresponding angles postulate just says if two parallel lines are cut by a transversal, then corresponding angles are congruent. Well, in these proofs we're going to be making use of the converse of the corresponding angles postulate. And the converse of the corresponding angles postulate just says if two lines are cut by a transversal so that corresponding angles are congruent, then the two lines are parallel. So what you're going to see is in the proofs that we did before, we had two parallel lines and we were trying to show that certain angles were congruent or supplementary. In this case, we're going to be looking at some theorems, some proofs involving lines that we're going to try to prove that those lines are parallel. And this postulate is going to become very handy in doing that. Now, another postulate that we're going to be using in these proofs is called the congruent supplements postulate. And the congruent supplements postulate says if two angles are supplementary to the same angle, then they are congruent. And a picture may help to illustrate this postulate a little bit better. Let's say we had two angles, angle 1 and angle 2, and let's say angle 1 is supplementary to angle 2. Well, if I had another angle, let's say angle 3, and let's say angle 3 is also supplementary to angle 2. Well, just looking at this picture, if angle 1 is supplementary to angle 2, and if angle 3 is supplementary to angle 2, then it's not too hard to see that angle 1 and angle 3 are going to be congruent since they're both supplementary to the same angle. And that's all this postulate says. If two angles are supplementary to the same angle, then they are congruent. And we're going to be using that postulate in our proofs as well. Okay, so earlier we looked at the parallel line theorems, and there were 4 of them. If two parallel lines are cut by a transversal, then alternate interior angles are congruent, same side interior angles are supplementary, alternate exterior angles are congruent, and same side exterior angles are supplementary. These were our 4 parallel line theorems. And they all have this same format. The if part, the hypothesis is, two parallel lines are cut by a transversal, then you can say something about the pairs of angles. Well, our parallel line converse theorems, they also have a similar format to each other, and they're all going to be the converse of each of these parallel line theorems. So the first of our parallel line converse theorem says if two lines are cut by a transversal so that alternate interior angles are congruent, then the two lines are parallel. And you can see this looks very similar to the corresponding angles converse postulate that we just saw. If two lines are cut by transversal so that same side interior angles are supplementary, then the two lines are parallel. If two lines are cut by transversal so that alternate exterior angles are congruent, then the two lines are parallel. And finally, if two lines are cut by transversal so that same side exterior angles are supplementary, then the two lines are parallel. All right, so again, you can see that each one of these has kind of that has the similar format. Now, let's take a look at how we would go about proving these parallel line converse theorem. So the first one we're going to take a look at is a proof of the alternate interior angle converse theorem. All right, so if we write the alternate interior angle converse theorem in given prove format using this diagram over here, then it would look like this. Our given statement is angle 1 is congruent to angle 8. So here's angle 1 and here's angle 8. And you notice these are alternate interior angles. And we're trying to prove that line K is parallel to line L. All right, so let's see what this would look like. Our first statement is going to be angle 1 is congruent to angle 8. That's going to be our given statement. And now, as before, when we solved, when we did the proof of the alternate interior angles theorem, what we would like to do in this case, we're going to again be using the postulate, the corresponding angles. This time we're not going to be using the corresponding angles postulate. We're going to be using the corresponding angles converse postulate. And the corresponding angles converse postulate, remember, tells us that if two lines are cut by a transversal so that corresponding angles are congruent, then we can say that two lines are parallel. So if we could find a way to show that these two angles here are congruent, then we'd have corresponding angles congruent, and we would know that line K and line L are parallel. Well, just like before, since I've got that angle 1 and angle 8 are congruent, and since angle 8 and angle 3 are vertical angles, then I know angle 8 must be congruent to angle 3, and therefore angle 3 must be congruent to angle 1. So here's what this proof is going to look like. Angle 1 is congruent to angle 8. That's given. My second statement, I want to say angle 8 is congruent to angle 3. And the reason I know angle 8 is congruent to angle 3 is because of the vertical angles postulate. That just tells me that vertical angles are always congruent. My next step, since I've got angle 1 congruent to angle 8 and angle 8 congruent to angle 3, I can say that angle 1 is congruent to angle 3, and that uses one of the properties of congruence. It's using the transitive property of congruence. So now I've shown that angle 1 and angle 3 are congruent. Well, since angle 1 and angle 3 are congruent, they're corresponding angles. Now I can use my corresponding angles converse postulate. So I can say now, I know that line K and line L must be parallel because of the corresponding angles converse postulate. The corresponding angles converse postulate says if two lines are cut by a transversal so that corresponding angles are congruent, then those two lines must be parallel. And I have two lines cut by a transversal, and I've shown that corresponding angles are congruent. Therefore, line K and line L are parallel. All right, now let's take a look at a proof of the same side interior angles converse theorem. And again, I have that theorem written here in given prove format. It says given angle 1 is supplementary to angle 4. So here's angle 1 and here's angle 4. And I'm told these two angles are supplementary. So let me go ahead and write that down. Angle 1 is supplementary to angle 4. So that's my given statement. Now, in this proof, I'm going to make use of the congruent supplements postulate that we learned. That is, if I've got two angles both supplementary to the same angle, they must be congruent. And I'm going to use this angle here again. And notice that angle 4 and angle 3, those are supplementary angles. So essentially what I have here is that I have angle 1 is supplementary to angle 4. That's given. I have angle 3 is supplementary to angle 4. I know they're supplementary because they form a linear pair. So I've got two angles here that are supplementary to the same angle. Therefore, these two angles, 1 and 3, must be congruent. That's what the congruent supplements postulate tells me. So since I can show that angle 1 and angle 3 are congruent, I can once again use the corresponding angles converse postulate to say that line K and line L are parallel. So let's see what that looks like. Step 1, angle 1 is supplementary to angle 4. Step number 2, I want to say angle 3 is also supplementary to angle 4. How do I know that angle 3 is supplementary to angle 4? That's the definition of a linear pair. Linear pair angles are adjacent and supplementary. So now I have angle 1 supplementary to angle 4. I have angle 3 supplementary to angle 4. Well, now I know that angle 1 and angle 3 must be congruent because that's what the congruent supplements postulate tells me. The congruent supplement postulate tells me if two angles are both supplementary to the same angle, then those two angles must be congruent. Well, now, once again, I have a pair of corresponding angles that are congruent, and since these pair of corresponding angles are congruent, I know that line K must be parallel to line L, because if I have two lines cut by a transversal so that corresponding angles are congruent, then I know that those two lines must be parallel, and that is the corresponding angles converse postulate. Now, in your notes, you have two more proofs to do. One of those proofs is going to be very similar to example number 1, and the other proof is going to be very similar to example number 2. So I'm going to leave those for you to try on your own, and we're going to take a look at those examples in class tomorrow.